These rational equations, we won't be able to use cross multiplication to solve like we did in the previous video because we do not have one fraction equal to another fraction. There's three of them in here. So instead, the trick that I'm going to show you is using the least common denominator to eliminate fractions. Pretty much the same thing we did when we eliminated the fractions within complex fractions. And so let's go ahead and take a look at how this method works. By the way, this will work for problems that you could cross multiply for as well. And it's a way to avoid anything like x to the third if you end up with something that becomes a large power of x when you cross multiply. So let's go ahead and find the least common denominator of all of these pieces. Looking at all three of those, I can see that my least common denominator is 4x. If you need help finding the least common denominator, go back and watch one of my previous videos and you can see how to do that. So what I'm going to do now is multiply only the numerators, each numerator only, by 4x. Multiplying the numerator of a series of fractions by the LCD will have the effect of eliminating the fraction for you. So if I look at each individual piece then, what I have is an x in the top and an x in the bottom right there, so those will cancel out, leaving behind just 4 times 5, or 20. No longer a fraction with that first piece. The next piece of this has a 4 in the top and a 4 in the bottom, so those are eliminated. So I have plus 7x. And then finally an equal sign. Once again, I have an x in the top and the bottom, so what's left is negative 9 times 4, which is negative 36. And just like that, look what I've done. I've gone and I made a much easier equation to solve. I started out with something rational that had fractions in it, and now something that's just linear and very easy to solve. So I'll subtract 20 from both sides, so I get 7x equals negative 56. And I'll divide both sides by 7, so I end up with an answer of negative 8. Now, before I just circle that and move on, it's worth noting whether or not this would make an extraneous solution. Remember, we're working with rational equations, with rational pieces up here, and I'm never allowed to divide by 0. So you always have to make sure that make sure your x value does not result in dividing by 0. And in this case, it's fine. If I plug in negative 8 for x, that's not a problem at all. X can be negative 8. It's not dividing by 0. Okay, so that's using the LCD to eliminate fractions. If you think you've got the idea, go ahead and try this one on the bottom. Pause the video and try this one on your own. Otherwise, I'll kind of talk you through this one real quick. So the first thing that I'm going to do is make this a 2 over 1, just so that I can see the fraction in there and just help me remember what I'm supposed to multiply. So building my LCD between all of the pieces, I can see my LCD this time is going to be 3x. So what I'll do to eliminate the fraction is multiply just the numerators by 3x, not the denominators. So multiply everything by 3x. Now the reason I put that 2 over 1 is to remind myself that, hey, that numerator needs to get multiplied as well. Don't forget to multiply that one. All the numerators on both sides. What's going to happen now is my denominator should cancel out and leave me with something that no longer has fractions in it. So this first piece, there's an x in the top and an x in the bottom. Those will get eliminated. 3 times 2 is just 6 for that, no more fraction. If there's a fraction left over, you've done something wrong. Next up, the 3 is the same in the top and the bottom, so those get eliminated. So 4 times x is just 4x. And finally, nothing gets eliminated in that last part of the problem, that 2, but that's okay because it wasn't even really a fraction to start with. We just made it look like a fraction, so I don't need to worry that nothing cancels out. So once again, I've gone from something rational and complicated and scary looking to something much less intimidating, something that's just a linear equation. So solving this, I'll subtract 4x from both sides, so 6 is equal to 2x, and then dividing both sides by 2, I get an answer of 3. Once again, it's worth checking to see if we'd end up with an extraneous solution. Plugging in 3 for x would be just fine. There's not going to be a problem. It's not going to result in dividing by 0, so 3 is my solution.